So, yesterday we talked about, oh, do you guys have questions on the exit slip? We only had to do the bottom one, right?
Andy needs help with her homework. Can she come in after school?
Not today, but tomorrow. Because I have meetings today after school.
Right after school.
At like 3 or 3:30 I'd be free, but oh, it's before school tomorrow.
Do all the math people have?
Most of us. You could ask him. I was before school tomorrow, I'll be here. Okay. Alright, did anyone have questions on that exit slip? Okay, cool. So, yesterday we talked about solving absolute value equations, right? On Monday, no, on Friday we talked about solving inequalities, correct? Today we're going to combine the two things. We're talking about solving absolute value inequalities. So, we get started here. If I'm looking at this inequality, solve the absolute value of x is greater than 2. What kind of numbers could work for that? 2, right? 'Cause it's greater than or equal to 2. The absolute value of 2 is 2, which is equal to 2. That would work. What other numbers would work for that? What do you say?
-2.
Negative 2. Negative 2. Absolute value, that's positive 2, which is equal to 2. Anything else? 100 would work. Absolute value of 100 is 100. It's greater than 2. What about like negative 100? Yeah, that would work. Anything equal to or greater than 2 or equal to or less than negative 2 works for this. Well, if you look at the graph for it, what kind of graph does that look like that we've seen? An OR graph. Whenever we have an absolute value problem that is greater than or equal to, we're going to change it to an OR problem so we can solve it. So our connecting word is going to be OR. Alright? So if it's greater than, the connecting word is OR. We call it a GOR, right? G-O-R. Greater than OR. We say GOR. It's just a kind of way to remember it. If you don't want to remember that, don't. It's up to you, right? Just a little thing to help you. Alright? Now, when we solve it, what's going to happen is we need to get rid of our absolute value so we can actually solve it. Because yesterday we talked about solving absolute value equations. We couldn't do anything in here until we got rid of them, right? Until we got rid of the absolute values. Same thing today. We got to get rid of them by changing it to an OR statement. Now, there's two ways to do it. There's this way, and then I'll show you another way that I actually like better. What's going to happen is you're going to keep one of them the exact same, just drop the absolute value. Take 3x minus 5, this will be greater than 16. And then we're going to say, or 3x minus 5 is less than negative 16. Just how we said x could be greater than 2 or less than negative 2. This could be the same thing here. We're going to say either greater than 16 or less than negative 16. Now, there's another way you could write that second part that make it a little bit easier to remember. You'll always have 3x minus 5. So I'm going to start with that. And if you want, you can keep this symbol the same and just put it on the left side and make it negative 16. Solve it that way. These mean the exact same thing. Now, you may have learned this way already. You're more comfortable doing it that way. You may like this way more. Do it that way. Doesn't matter. It's up to you. Alright, so if you want to remember that I have to flip the sign and make it less than negative 16, do it like that. Otherwise, keep the sign the same and make it negative 16 on the left. Does that kind of make sense? I just threw a lot of information at you at once. Alright? We'll practice it, we'll get better at it. I promise. Okay? So, either way we do it, we're going to solve them. So now that I got rid of my absolute values, I can solve. Add 5. Add 5. I get 3x is greater than 21. I divide by 3. X is greater than 7. Or, add 5. 3x is less than negative 11. Divide by 3. X is less than negative 11 thirds. Now, is that how we should probably write our answer? What did we practice on day 2? The smallest one goes first, but we practiced interval notation, right? Hey, let me give you a little hint. You should really, really practice that. Because if I had to guess, I mean, I don't like guessing, but if I had to guess, all of our answers are probably going to be written in interval notation on the test. So we should really practice writing it like that, okay? So, if I look at this first equation here, did it ask us to graph this or just solve it? Solve it. Okay. If I know x is greater than 7, what's the smallest value I'm going to use in my interval? 7. Right? And it's going to be a parenthesis because it's open. It's not or equal to. If it's greater than 7, it's going to what? Infinity. Positive infinity. So it'd be 8, 9, 10, 11, all the way up to infinity. So it's going to be 7 to infinity with a parenthesis. Or x is less than negative 11 thirds. Well, if it's less than that, it could be like negative 4, negative 5, negative 6, negative 7, negative 8, all the way down to negative infinity. And the biggest value we're going to use is negative 11 thirds. We're going to use this value always, whether it's included or not. If it's not included, it's just a parenthesis. And then like Natalie said, our smallest one's got to go first, so we got to switch it around. Switch your order to negative infinity to negative 11 thirds, or 7 to infinity. Did it ask us to write an interval notation? No. But, like I said, I would probably make sure I'm really practicing that and getting help on it if I don't know how to do that, because that's going to be a really, really important part of our test. Maybe, if I had to guess. Okay? Yes, Ange?
Is there an easier way to do infinity? I always end up writing it.
Opposite
Okay,
ends.
yeah, there you go.
2 circles. Being in touch. Okay? Now, if you're trying to do infinity and you get something that's like really flat like that, I know what you're trying to write. I'm not like, if you don't have the perfect infinity signs, it's fine. I'm not going to mark you wrong. I know what you're trying to get at. Now, if you struggle with the infinity sign, like I said, just put 2 circles next to each other. Make an 8 that's sideways. Okay? Alright. Now let's look at x is less, the absolute value of x is less than or equal to 2. Well, what kind of numbers would work for that?
0.
1 would work, 0 would work, right? Absolute value of 0 is 0, which is less than 2. Absolute value of 1 is less than, absolute value of 1 is 1, which is less than 2. Excuse me. Negative 1 would work. Absolute value of negative 1 is 1, which is less than 2. Anything greater than negative 2 or less than 2 will work. Well, what kind of graph does that look like? An AND graph. So if I have a less than or equal to problem, it's going to turn into an AND statement. So my connecting word is going to be AND. We say land. Less than and, greater than or. So gore and land. Like I said, if you don't want to remember those 2 words, don't. I don't care. Just to try and help you. Alright? So land and gore. Now, with an AND statement, we said there are 2 ways to write them, right? You could write it as 2 separate inequalities with the word AND in between. Or you can make it a compound inequality, right? Now, I'm going to do the compound inequality way. If you want to break it into 2 separate ones, that's perfectly fine. I just think the compound inequality is a little bit easier. So, when we're trying to do that, just like with x, we said x could be anywhere between negative 2 and 2, even though it's just 2 here. With these, if I had the absolute value of 3x minus 5 is less than or equal to 16, I'm going to put it between 16 and negative 16. That way I can drop my absolute value sign and I can solve it. So once you have it down to just its absolute value and it's a less than statement, to get rid of our absolute value so we can solve, we're going to set it less than or equal to 16, and then it's going to be greater than or equal to negative 16. Your sign shouldn't change with these AND problems, unless you obviously multiply or divide by a negative, but when you're setting it up, it shouldn't change. So you take the opposite and you put it on the left. So if this had said 32, I'm going to take negative 32, put it on the left, make it a compound inequality to solve it. Make it an AND statement. Alright, does that make sense? Ish, at least?
No.
Okay. Do we have any questions before I keep going? Okay. Once we get to this point, we can solve it, right? We got rid of our absolute value signs. We can go ahead and solve. So I add 5 to all three sides. Negative 11, less than or equal to 3x, less than or equal to 21. Divide by 3 to all three sides. Negative 11 thirds, less than or equal to x, less than or equal to 7. Yes, I'd really prefer if you left that as a fraction. If you really want to write it as negative 2.66 repeated, that's fine as long as you use the repeated symbol. Please do not round. Do not leave it as 2.67. That's not the same. When I'm here, should I leave my answer like that? No, we just talked about that. We're going to write an interval notation. Well, I know x has to be between negative 11 thirds and 7. So what's the smallest value that x could be to satisfy this? Negative 11 thirds. Is it a bracket or parenthesis? Bracket, because it's or equal to. 2, what's the biggest value this is going to be? 7, good. And it's a bracket because it's or equal to. Alright, that's my answer. Does that make sense? Should we try some more? Okay, let's try some more. Solve and then graph. Absolute value of m minus 2 is less than 8. Like I said before, the first thing we should try and do is make sure our absolute value is by itself. Alright, is that the case here? Is it on its own side?
Yeah.
Yes. Okay, is it a less than or a greater than that we're working with? Less than, so it's going to turn into an and problem. So turning into an and problem, we're turning into that compound inequality. I have m minus 2 is less than 8, and I'm taking the opposite and putting it over on the left. So negative 8. Okay, because it's an and, I take the opposite, put it on the left. Negative 8, less than m minus 2, less than 8. I need to make an and statement so I can solve it. So how do I go about solving this? Plus 2 to all sides. Negative 6 is less than m is less than 10. Like I said before, let's practice our interval notation. If I were to write this in interval notation, my smallest value is going to be negative 6. My biggest value is going to be 10. They're not or equal to, so they're both parentheses. Now, if it helps you, graph it first, then do the interval notation, okay? Thank you. Ooh. So if I go to graph this, I should have one endpoint at negative 6. Is it an open or a closed circle? Open. Good. One endpoint at 10. Is it an open or a closed circle? Open. And I should shade where? In the middle. Good. So then you can look at your graph and see, well, I know negative 6 is the smallest it'll be, to 10 is the biggest it'll be. They're both open, so they're parentheses. Okay? Does that kind of make sense? Okay. Do we have any questions before I move on to the next one? Okay. Our next one, absolute value of x plus 5 is greater than or equal to 11. First thing you need to do, make sure you get your absolute value by itself. How can I do that? Minus 5, subtract 5. Absolute value of x is greater than or equal to 6. Guys, why do you think I'm going to have you get that absolute value by itself first before we do anything else? Why do you think? We might have to multiply or divide by a negative to do that, right? So I can't check and see, is it less than or greater than right away? I might have to multiply by a negative or divide by a negative to solve for that absolute value, which would flip my sign. So you need to get the absolute value by itself first, and then check and see, is it less than or greater than? Well, in this case, is it less than or greater than? Greater than. So it's an or statement that I'm going to make. Like I said, there's two ways we can go about doing this. The first one, we keep x greater than or equal to 6. We just drop the absolute value. Or we take x, we flip our sign, and make it negative. That's the first way you could write it. Or if you want to keep that same sign the whole time, just like we did with and, I would take, well, this first part, x greater than or equal to 6, or, and I would take the sign on the opposite side and make it negative 6. Either one of these works. These are the same things. They're just written in a different order. Alright, whichever way you're more comfortable doing. Doesn't matter. Alright, and then do I have to solve these at all? No, right? They're already solved out. I don't have to do any solving. Do you guys like doing it the green way or the blue way better? The green way where you flip the sign and make it negative? Okay, we can stick with that. If you like doing the blue way, do not stop doing it that way. Keep doing it that way. Alright, I'm just going to keep doing it the green way because that's what seems like the majority of people want. Okay? So when I go to graph this, x is greater than or equal to 6. At 6 I have a filled in circle, and I'm shading to the right. X is less than or equal to negative 6. At negative 6 I have a filled in circle, I'm shading to the left because it's less than. Well, I need to write my interval notation. If I look over here on the left side of my graph, what is the smallest number that is going to go to? From the left part of my graph, sorry, I'm not the interval. Negative infinity, right? This is going to keep going all the way to negative infinity. What's the biggest number it's going to be? Negative 6. And I'm including it because it's a closed circle. Or, what about this side of my graph? What's the smallest number? 6. And where's it going? Positive infinity. So that's how I write an interval notation. Now they actually switch sides, right? The negative 6 one on the left, positive 6 is on the right here. But I worked off the graph. Okay? Does that make sense? Yes, no. How many out of here today? 29? 29, right? It's a Wednesday? Okay, how much do we have left here?
2 more.
2 more?
Yeah.
Alright. We only get one of them. Alright. Johnny, left or right? Left. So we're going to start the left one. If we can get the right one, we'll do that one as well, but we're just going to do the left for now. Okay. How do I start this problem? What should I do first? Add 10, right? Get that absolute value by itself. Add 10. 9 times the absolute value of r minus 2 is less than 63. Then I'm going to divide by 9. The absolute value of r minus 2 is less than 7. Alright, my absolute value is all by itself. Is this a less than or a greater than problem? Less than, so it's going to turn into an? Land, an and statement. To do that, I keep r minus 2 is less than 7. Take the symbol, and I take the opposite of 7 and put it on the left, which would be negative 7. It's going to be anywhere between negative 7 and 7, and it's going to fit my answer, because I take the absolute value of it. So then I write plus 2. To solve for r, I get negative 5. Less than r, less than 9. Well, let's graph that. Negative 5, open or close circle?
Open.
Good. 9, open or close circle?
Open.
And I'm shading in the middle, because it's an and statement like this. So, let's see, who can I pick on? I don't want to say pick on, but Izzy, can you help me write the interval notation for this, please?
Parenthesis negative 5, comma 9, parenthesis.
Perfect, right? So negative 5 is the smallest it'll be, 9 is the biggest it'll be. They're both parentheses because they're open circles or they're not equal to. Good. Alright, do we think we can run through the last one in 3 minutes?
Yes. Yeah.
Alright, let's sprint through it. Same thing, get your absolute value by itself first. Minus 6. 9 times the absolute value of 3n minus 2 is greater than 45. Divide by 9. Absolute value of 3n minus 2 is greater than 5. Well, it's a greater than, so it turns into an or statement.
Or.
So, 3n minus 2, greater than 5, I keep that, or 3n minus 2, I flip the sign, and I take the negative, I take the opposite of 5, which would be negative 5. Then I solve them both. Plus 2. 3n is greater than 7, divide by 3. n is greater than 7/3. Or, add 2, 3n less than negative 3, divide by 3, I get n is less than negative 1. So all I did is I saw it was a greater than, I changed it to an or statement, I solved them both. I go to graph it, n is greater than 7/3. So at 7/3, which is approximately 2.33, I have an open circle, and I shade to my right because it's greater than. At negative 1, I have an open circle. I'm going less than, so I shade to the left. My interval notation for this, the smallest it will ever be is negative infinity to negative 1, and I'm not including it, so it's a parenthesis. Or 2 1/3, which is 7/3, excuse me, to positive infinity. Whew, just made it. All right.